Hello everyone. In this video, let's discuss about the first order RC circuit response to a this given input signal. You can see here this is a first order circuit. To find whether this is a first order RC circuit, go through my previous videos. You will know how to find this is a first order RC circuit. So let's see here. We have a starting the voltage source. Let's assume and this is t by 2, sorry, this is 0 seconds, and this is t by 2, this is t, this is 2t by 3. Okay, so till t is equal to 0, the input voltage is 0, and I am taking here the capacitors which has initial charge of 0 volt, so that vc2 will be 0 and vc1 also will be 0. You can see at t is equal to 0, the high frequency signals are being applied to both capacitors C1 and C2. Okay, so if we see here, if I draw a equivalent circuit here, this will become like this. So this will be one resistor, one capacitor. Because of high frequency signals, it will get short circuited, and the same way the capacitor here C1 also will get short circuited. So before I go further here, I forgot to tell one thing. So here you can see here 0 to t by 2. So t by 2 is far greater than time constant of this circuit. Here this time constant is R into C1 in parallel with C2. Okay, so that if the capacitor starts charging, it will directly within 0 to t by 2 time itself, it will charge from 0 to full V in the same way do at t by 2 to t, it is there from 5 to, let's take V to 0 volt. Okay, so it will discharge from 2 till 0 volt within this t by 2 to t time. Okay, here the signal is 0 volt V volt, this is 0 volt, this is V volt. Okay, at t is equal to 0, you can say that the two, because two capacitors are short circuited, the resistor will, the no current will flow through the resistor, because the current will take the least resistance path. Okay, the current will flow here. If I calculate what is the current flowing through here, this is V, this V divided by R. Because R is 0, infinite amount of current is flowing through the circuit. Okay, because this infinite amount of current flowing through the circuit, the capacitors C1 and C2 will instantly get charged, so that you can, at t is equal to 0 itself, they will get charged. Let's assume that vc1 at t is equal to 0. If I calculate, these two capacitors will come in series with a v in, so that if I apply a voltage division rule, v into c2 divided by c1 plus c2 for vc1, the same way vc2 equal to v into c1 divided by c1 plus c2. Okay, so vc2 went to this voltage, this vc2 voltage, so this is vc2. In the same way, vc1 went to vc1 voltage. Okay, this is till here. So let's see. So we know that from 0 to t by 2, this circuit will go to steady state values. Okay, steady state nature, that means it will behave as a step circuit. So let's forget this transition. The circuit will behave as a, in such a way that you have given a step signal, so that means the capacitors will reach to their t equal to infinite state at dc conditions. Okay, at, let's assume if you give a step signal to this circuit at t equal to infinity, what will happen? This capacitor will get open circuit, this will also will get open circuited. Because this capacitor is open circuited, no current is flowing to the circuit, I is equal to 0, so that vc2 will become v in. And because there is no current flowing to the circuit, the current voltage across the resistor is 0, and the voltage across the c1 capacitor is also 0. That means here vc2 is being charged to exponentially to sorry, little bit mistake here in the waveform. So this will this vc2 will charge to v volt. So this is v volt with the time constant of tau, which is r in parallel with r into c1 in parallel with c2. Okay, in the same way vc1 will from c1 will discharge from vc1 volts to 0 volt. Okay, within same time. Okay, this time should be equal to 0. Okay, here it will be 0. Okay, at t equal to t by 2, something again is happening here. The high frequency signals are there. The voltage, input voltage, is changing from v volt to 0 volt. Okay, so because of that, again let's redraw what is the equivalent circuit again at t equal to t by 2. If I redraw t at t by 2, if I redraw the circuit, this will become like this. Okay, this, let's assume this is plus, this is minus, this is plus, this is minus. At t by 2, the voltage will become 0, so that that voltage source will get short circuited. Okay, and there is a capacitor with some voltage of some, this is plus and minus, is some voltage v, and because of high frequency the capacitor is also short circuited, and there is a one more capacitor which is 0 volt, and there is a resistor here connected. Okay, so this is what it is happening. So because there is a capacitor here which is again short circuit, so you can say that at t is equal to 0 itself, so we can say that there is a infinite amount of current is again flowing through capacitors C2 and C1, because the current will take the least resistance path. Because of this infinite amount of current, the charge inside the capacitor C2 will equally will distribute to C1 also. Okay, so how will it get distributed? So let's rewrite again. So if I rewrite like this, um, this is v1. So previously this was minus, this is plus, this is plus, this is minus, this is C2, this is C1, this is C1, this is C2. Okay, previously how much was voltage V? Okay, so we need to say that we can rewrite this C1 and C2 into single capacitor. So generally we say that capacitor Q is equal, charge in capacitor Q is equal to CV. In same way, if I write in terms of equivalent, so if I at t is equal to 0 itself, the capacitor should uh, um, exchange between C1 and C2, because there is no current flowing through the resistor at t is equal to 0 itself. So the charge inside C2 will exchange with C1 and it will come to the stable point. Okay, so that I can rewrite as Q equivalent equal to Q1 plus Q2. This is charge in Q C1 and C2. Okay, C equivalent into V equal to C1 into V1 plus C2 into V2. Okay. In the same way, if I want to calculate V final final at t is equal to T2 plus, it will become, so here you can say that V1 is a C1 voltage will be zero at that t by 2, so that this will become 0. So that equivalent voltage will be C2 divided by C2 into V2 divided by C equivalent. So this is the voltage will be at this T by 2. Okay, at T by 2. Okay, so suddenly the voltage here it became 2. Let's assume this is V1. Okay, it went to V1. Okay, it went to V1. In the same way, you can say here VC1 has a negative voltage. So it when it charged to, so previously the convention was, um, if I have a plus here, so I think this is wrong which I have mentioned here. So this is plus here, this is minus here when the doing charging. So if there is a potential positive this side, then I should consider as a positive voltage. But here the voltage became reverse. Okay, so here the capacitor is being charged with this here plus and this here minus, so that I can represent it as a minus V volt. Okay, whatever the charge it is being coming, minus V1 volt. Okay, the capacitor again. So this capacitor C1 went to negative, which is minus V1. Okay, so minus V1. From there again, these two capacitors will discharge to the resistor and will become 0, because this time constant is far less than t by 2 to t time, so that this voltage will again come to 0 volt. In the same way, VC1 also will come to 0 volts and stay here. Again this voltage will again this same sequence will again repeat to the t2 2 by the same waveform will repeat again from uh, t to 2t by 3 time period also. So I have simulated the same thing. Let's see how it is looking. So this is the what I have given. So it has 1 microfarad capacitors. Both are equal. This is C1 and C2, both are equal, and 50 ohms resistance I have kept. See here I am giving Vn as 0 to 1 volt and 0 to 1 volt. So here we can see that C capacitors are instantly charged to V volt 1 volt, and VC2, you can see VR is equal to VC1, sorry, VR equal to VC1. Previous it was zero point 0.5 volt. Here also it should charge to zero point 0.5 volt starting, and zero point 0.5 volt it suddenly went to 0 volt with the time. Okay, in the same way at t is equal to t by 2, again the voltage of the VC1 went to zero point 0.5 volt. Here we can say it generally might went to zero point 0.5 volt. Here it might also went to VC1 also, VC2 also went to zero point 0.5 volt. Here if we see from t by 2 to t time, the VC2, this is VC2, this is VC2, this is VC1. So VC2 also became 0, and VC1 also VC1 is also become 0, VC2 is also become 0. Here you can see there is a sudden spikes in the currents. These are because of when two capacitors are being short come in parallel, so that the instantly at that point only the huge current is flowing, and charge is being distributed between two capacitors.